Hi guys, welcome to this tutorial where I'm going to be showing you how to interface an ATtiny85 microcontroller with a SX1276 LoRa radio module. So if you've been wanting to make your project really smaller and use an ATtiny85, but you don't know how to use the ATtiny85 with the normal Arduino LoRa library, I am going to show you how to make it work for the ATtiny85. So please make sure you stick around until the end of this video. Without wasting time, let's get started. So here's a quick overview of what we're going to be discussing in this tutorial. The items that are in bold, the items that we're going to be focusing a little bit more on, and the items in gray are part of the process, but I'm not going to explain how they work or explain in detail how I've used them to do some of the steps in this tutorial. But the goal of this tutorial is to show you how to use the the Arduino LoRa library to make it compatible with the ATtiny85. So the reason why the Arduino LoRa library doesn't work for the Tiny85 is because this library uses the Arduino SPI protocol, which works completely different from the ATtiny85 SPI protocol. So the idea is to interface an ATtiny85 with a LoRa radio module, and these two, they communicate using the SPI protocol. So we are going to modify the Arduino library so that we can replace the Arduino SPI with the ATtiny85 SPI protocol. And then after that, we'll be able to use this SPI for the we'll be able to use this library for the Tiny85 as a normal Arduino LoRa library. So after that, we're going to transmit some data from this left node, which is going to be the LoRa transmitter or the LoRa sender, to a receiving LoRa node, which for this we're going to be using the ESP32 OLED development board. So these are the brief steps. I'm going to explain shortly the ATtiny85 SPI protocol. And then after that, we're going to integrate this into the existing LoRa library of Arduino. And then after that, we are going to write a very short program to transmit data using the Tiny85. And then another short program to be receiving this data with the ESP32. And for the ESP32, we're going to be programming with the platform IO. And then we're going to do the wiring and then the testing. So what I'm going to do now, I will show you the brief SPI protocol. So this block diagram comes from the ATmel datasheet. So basically you have a master and a slave. And then this block is a 1 byte of data that is being exchanged between the master and the slave. And then the master is generating a clock synchronized between the two devices, and then the other two lines are the data lines. There's data in coming into the master, but this is the data out coming out of the slave. And this process is simultaneous. When data is being pushed out of the slave of the master, is simultaneously being pushed into the slave and vice versa. So it takes a bit of time to explain the full protocol. It's very easy to understand, but if you want me to make a separate video explaining this protocol, a very simple protocol, but really very powerful and exciting, please let me know in the comments of this video. But I'm still going to show you briefly in the ATmel datasheet for the this device. Of course, it's valid both for the Tiny25, 45, and 85. They use exactly the same hardware, but we're going to be specifically focusing on the Tiny85 because it's the one that I'm going to be using for this project. So if you go to section 15 of this datasheet, you see there's a USI description, Universal Serial Interface. This interface is the hardware of the ATtiny85 that is reconfigurable to either being used as a 2-wire mode or 3-wire mode. The 2-wire mode is your I2C protocol. 3-wire mode is your SPI mode, which we're going to be using in this case. And we're going to be using it in master mode configuration. So our Tiny is the master and the LoRa module is a slave. So I highly encourage you to go through this datasheet and read this chapter. If you have any questions, you can ask in the comment section. But it's pretty straightforward to understand, not too difficult, and also not too difficult to implement, as you shall see later on. So here's your hardware. Then the block diagram which I showed you earlier is also described here. And then what is even more important is the timing diagram of how exactly the data is exchanged between a master and a slave. Next to that, they give you a small assembler code which describes exactly how the transaction is executed when you want to exchange 1 byte of data between a master and a slave. That's all you have to do. This very short piece of code, very simple. But you're going to implement this in C++ language, not in assembler. And there's also a description of the various registers. This is a 2i mode. We're not considering that in this case. I will show you also here, starting from this 15.5, they describe all the various registers that is used for the SPI protocol. Okay, I think that's already enough. So going back to the presentation, I will also show you quickly what we saw in the datasheet. This is the software side of the SPI protocol. It's a very simple procedure. First of all, we have to configure our pins. These are the pins that we see as per the pinout diagram of the ATtiny85. So you have to configure your clock, your data in, your data out pins as either inputs or outputs, depending on the direction of the data. So I can refer you quickly to the pin configuration of the ATtiny85. So you see here there's a data in, there's a data out, and there's a clock. This is what we use for the SPI protocol. So the data in is configured as the input, the data out is configured as output, and the clock is configured as the output because this master is going to be generating the clock. Okay. And then when the pins are configured, then we do the actual data transaction, which in this case starts by transferring the SPI data that you want to send to the slave. We put in the SPI data register. And then there's a status bit that we must clear, the overflow bit, which is counting the number of clock edges to indicate that the 1 byte has been transferred. So as long as the flag is not set yet, we keep on doing this transaction here. And then when the transaction is done, in other words, the overflow bit is set, we at the same time retrieve the data from the slave. So the received data is sent back into the data register of the slave, of the master, sorry. So that's it. It's a very simple procedure. So I'm going to show you how to integrate this into the Arduino LoRa library so that we can use the LoRa library as usual. Okay, so if you go to your documents folder, there's a Arduino folder, which is a hardware and a library subfolder. In the libraries, if you have installed some libraries in your Arduino IDE, the respective folders, they will appear here. So in this case, I've already installed the normal LoRa library in the Arduino IDE, and it was here before I renamed it to the LoRa ATtiny85. So it's either you rename it or you don't. But what is very important is to go inside this library folder and go to the source files and we have to open these two files and modify them to integrate our ATtiny85 SPI protocol. So this library makes use, or at least every library uses, a header file and a C++ file. So I'll open these two files. In this case, I am using VS Code to modify these files. It's just a code editor. You can use Notepad++ if you want, or any other code editor convenient for you. Alright, so what I've done here, I have commented out all the Arduino relevant SPI stuff, and added a little bit of the ATtiny85 SPI items. So if you go through this file, I'm going to leave it in the description of the video. You'll be able to see what I've done. So yeah, I've commented out all the green things because they are relevant for Arduino. By the way, I'm going to discuss the header file first, and then later on we discuss the C++ file. So I've commented out Arduino, and here is the pins as I described earlier. Here I'm making the configurations here. I'm defining the pins first of all, the clock pin, the data pins, and the slave select pin. And then we also have the actual LoRa class here. This is the normal, what it looks like for the normal Arduino LoRa library. So in this class, we're going to add two functions for the ATtiny85. The first one is the begin ATtiny85, which we use to configure and initialize our ATtiny85 and get it ready for a data transmission over SPI. And then the other function is the send SPI ATtiny85. This is the actual data transaction function. This is the function which is going to actually execute the data transaction to send data over to the LoRa module. And then in this header file, the only thing that I will show you is the things that I've commented out, which I know are relevant for the Arduino SPI protocol. Here I've commented out Arduino stuff, and here I've commented out Arduino relevant stuff. Okay, so that's it in the header file. So we add new two functions. We define our SPI pins. So for the C++ file, we need to do the same procedure, commenting out irrelevant stuff and adding the relevant stuff. You see when you have access to this file that I've commented out Arduino items. Some of these things you have to figure out for yourself, but yeah, I've commented out the ESP32 relevant items here in this section. Here, Arduino relevant items. Most of the items are relevant for the normal SPI protocol used for the Arduino device. Then in the begin function, which we normally use in the IDE when we in the setup section, when we say LoRa.begin, this whole procedure here is relevant for the Arduino or ESP32 up to here. So what I've done is I've replaced that with tiny SPI begin, which in this case is simply over here configuring the pins and prepare the device for the SPI transmission. And that's it. We call that function here inside the LoRa.begin. When that is done, we carry on with the initialization. So all from anything after this is still relevant as for the Arduino. To get things started up to here, return A1, it means LoRa is ready, it has been prepared, it has been initialized. And then I'll also show you the actual implementation of the send SPI ATtiny85 function, which I described in the header file. Exactly what I showed you earlier. So we prepare the data first, clear overflow bit, and then do a data transaction until the overflow flag is set, then retrieve data from a slave, finish. So these are the only things that we need to do in terms of a new software or new code which is relevant for the ATtiny85 SPI. And then I'll scroll further down this file showing you what I've commented out, or if I missed something, you will figure it out. I've commented out stuff that is relevant for the Arduino SPI protocol. Show you as I go. Here, green stuff commented out, a lot of green there. And let's see what we also have further down. Another section commented out, Arduino relevant. And then I'll show you here where I've plugged in the actual transfer function. So these are two functions. We have a read register and we have write register. These are the functions that are used to read something from the LoRa module or to write something from the to the LoRa module. So for that, you must send the address that you want to read or write, and then you must also get something back. So each one of these two functions uses our transfer function, or the actual SPI transaction execution function that we've implemented above. So the green section is what the Arduino does, and this is what the ATtiny85 does using the software that I've described already. So first of all, we pull the slave select pin low, and then we send an address to the slave that you want to read or write. And then when that is done, we receive a response from the slave as the data back that we retrieve from the slave. When that is done, then we pull the slave pin high, and we make the data available for us. That's it. It is done. So this is how you actually speak to the LoRa module using this single transfer. Simply means a single transaction between the ATtiny85 or the Arduino actually and the actual LoRa module. So you have read register or write register depending on what you want to do. Okay, so that's it. We have now successfully prepared the Arduino library for use with the ATtiny85. Our last stop will be to do wiring and to do the programming of our devices. So here's a wiring diagram for your ATtiny85 interface to the LoRa module, the radio module. It's actually very simple. There's only one thing that you have to be very careful about. The MISO connection on the radio module, please make sure you connect onto the MOSI pin of the ATtiny85. And that goes for the MOSI pin as well. Master out, slave in. It's actually connected to the MISO of the ATtiny85. It's a bit weird, but when referring to the SPI of the ATtiny85, we actually talk about data out on the ATtiny85, which is actually on the other side, which is on the radio. It's master out, slave in. And data in on the ATtiny85 on the radio is master in, slave out. But when interfacing, for example, with Arduino with the SPI slave, MISO is connected to MISO, MOSI is connected to MOSI. So please don't be fooled. Be careful about that. You might spend a lot of time trying to find out what's wrong. Be careful about that. However, if you are programming your ATtiny85 with a serial programmer, like what I did with a USB ASP, it refers to the MOSI connections. So MOSI goes to MOSI of the programmer, and MISO goes to MISO of the programmer. And of course, clock is the same for everyone. For a programmer and for a slave, clock is always connected to clock. And that's it. The slave select pin, we used the PB4 from the Tiny84. Yeah, this is what we programmed in the library. And that's it for the diagram. So the next thing we want to do is to actually write a small program. I've already done that for you. So here, this LoRa library that I've included is the modified LoRa library for the Tiny85. And then we do everything else. And then we transmit a message and the packet number to the ESP device, ESP32. So for the ESP32, I've used platform IO to program this device. And for that, I've used the normal Arduino LoRa library, which is not modified, and done all these things until here where I receive the actual LoRa data and then I display the data on the OLED display. And that's the end of the actual major steps that we followed in this tutorial. For programming the ATtiny85, I used a USB ASP serial programmer. There are several ways of programming this device, but I'm not going to go into detail like I said in the beginning of this video. But if you would like me to specifically show you how to do this, please tell me in the comments below of this video. And for programming your ESP32, it's actually very simple, very easy. You simply need to plug in your cable, and this platform IO software picks up the device automatically. You simply need to hit upload, and it will be programmed. So when that is done, we are ready to test our devices, transmitting data from ATtiny85 to the ESP32. And that's about it. I hope you enjoyed this video, and I've left everything in the description box of this video. I've left all the software files, the LoRa library for Tiny85, the example code for the Tiny85 using the IGE, the example code for the ESP32 using the platform IO. I've also left the wiring diagram to interface the Tiny85 to the radio module. And you must be good to go. Please feel free to grab these items and experiment. And please tell me in the comment if you're able to use this library, or if you've been struggling and you finally managed to solve this. And if you found this video useful, please press the like button, and please share it with some people who might be looking for this information. And if you're new to this channel, please make sure you subscribe for awesome future content. I thank you.